Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on oil network modeling using Gap software. Alright, so in previous video, we have set the solver and optimizer parameters, and then we have rerun the prediction. So let's check it out. Prediction, run prediction, next, and then next again. Okay, so the computation has been completed. Now let's check the result. The first thing to analyze is the individual well performance. To do this, we go to main menu and then prediction. Now let's check the plot notes prediction results from the selection here. All right, and then let's go to check the well. I'm going to check all of our wells. Just click on like this. And I will also include the system totals. And then let's just plot. All right. Okay, and then let's go to the base case like this, or maybe we can click on this first like this and then plot the oil rate. This is for well 1A. And then do the same thing for 1B, 2A, 2B, 3A, lastly 3B. So these are the plots of oil rate from our 6 wells. Okay, alternatively, we can also do this. Remove. Select one of the wells from the top list. Like this. Select this one and then click on oil rate. All right, and then let me expand this. I will click on this, add multiple variables to the plot. Okay, and then let's check this like this, base case, well 1A through well 3B, and then click on OK. All right, very simple. Now you can see we have the plot of our wells. For the variable is the oil rate. And from here we can analyze. And you can see, let me show you the well 1A and well 2A. You see, we will suffer a problem here. From the plot, we can see that these two wells will die after just over 6 years. But if you plot other wells like well 1B, even if you compare well 1A versus well 1B, well 1A has, greater oil production rate, but it will not live longer than well 1B. Same thing with well 2A. If you compare well 2A and well 2B, of course, the oil rate from well 2A greater than the well 2B, but well 2B lives longer than well 2A. But of course, you can compare their cumulative. All right, so I'm going to plot cumulative oil production like this. Remove all first. Well 1A, cumulative oil production. And then this. Select all. Uncheck this. Uncheck system totals. Okay. All right, so well 3A has the greatest cumulative oil production. The second rank is well 2A. And then well 1A, you can see the red color there. And then, which one is this? Well 3B, and then well 2B, and lastly well 1B. All right, interesting. We can also plot the reservoir pressure as function of time by, I'm going to close it here. Okay, so let's check the prediction again, and then plot. Rather than nodes, we select plot tank prediction results. All right, and then of course, reservoir A and reservoir B, go to plot, interesting. And then let's find the base case. Maybe you remove series first. Reservoir pressure for reservoir A and reservoir B, reservoir pressure. Interesting, right? So from this plot, we can observe that the reservoir pressure of reservoir A drops below the bubble point pressure, which is 3,500 psig, after about 1 year of production. And the pressure is shown by these black boxes. But for reservoir B, this reservoir sees a steady decline. However, the reservoir pressure does not fall below its bubble point pressure. So it's very interesting. After the prediction, you can plot the result for the nodes. In this case, you can plot the performance of the wells, and you can also plot the performance of the tanks, the two reservoirs. All right, so to analyze the model in more detail, we will use the snapshots feature. In this case, the date at which well 1A dies is the focus of the investigation. So we will check the time at which the well 1A ceases to flow, and we will do further investigation at that time. But we will do that later in the next video. So until then, thank you and see you.